So we discussed that when we pass an electric current through ionic substances that are molten or in aqueous solution, they are broken down into elements, and this is known as electrolysis. And the substance that we break down is known as the electrolyte. Now in electrolysis, as we discussed, the positively charged ions will move towards the cathode or the negative electrode, and the negatively charged ions will move to the anode or the positive electrode. At the cathode, positive ions are going to gain electrons, which is reduction, since gain of electrons is reduction, and negative ions are going to lose electrons, which is oxidation. So let's look at examples of electrolysis to understand them better, and we're going to focus on the examples that have been given in the syllabus specifically. So first of all, if we want a substance to conduct electricity, either it should have free electrons or it should have mobile ions. So when you are taking an ionic substance in molten state, or when you're dissolving it in water, you are actually producing ions that are free to move within the solution, hence they can conduct electricity. So for example, when you have solid sodium chloride, the ions are held in a lattice, so they cannot conduct electricity, but when you take them in molten state, the ions are free to move, hence they can conduct electricity. It is all the difference between electrolytic conductors and electrical conductors is also very important to note, that electrical conductors conduct electricity by the flow of electrons, but electrolytic conductors conduct electricity by the movement of ions across the electrolyte. And electrical conductors remain chemically unchanged when current flows through them. For example, when you pass current through a metal rod, it will remain chemically unchanged. But when you pass electrical current through molten NaCl, there is going to be a flow of ions, and it's going to be chemically changed, because now the electrolyte will decompose to form different substances. Or if you add solid sodium chloride to water, it can easily dissolve because it's salt. You're going to form a substance called, what is another term for aqueous sodium chloride?
Salt solution.
Brine. It's known as brine. So that's why ions are once again free to move and electricity is conducted. So let's have a look at the electrolysis of molten sodium chloride. Now over here, if you take solid sodium chloride, we discussed that you cannot conduct electricity because they're not free to move. But if you take it in molten state, so ions are free to move. What happens when the battery is pulling away electrons from the anode? Initially, both of the electrodes are uncharged. The battery is pulling away electrons from the anode, so it becomes positively charged, and it is giving electrons to the cathode, so it becomes negatively charged. Now when the cathode is negatively charged, and we're talking about inert electrodes, so they're not going to react, so the positive sodium ions are going to be attracted towards the cathode, and then they're going to pick up an electron and sodium will be formed. So this is the ionic equation, and solid sodium is formed. And chlorine ions are going to move to the anode and they will give up an electron, and this is the ionic equation, the one below, because if this one is balanced, you cannot have chlorine in this state. So that's why you're going to write it as 2Cl, and then chlorine gas will be given off. So here solid sodium is being formed, but at the anode, chlorine gas will be given off, and it's going to escape. So this is how electrolysis took place. That was for molten sodium chloride. But now when we talk about aqueous sodium chloride, which is also known as brine. So here, how is it aqueous? What have we added to sodium chloride to make it aqueous? Water.
Water.
And water. It contains, and water also contains ions, which are hydrogen ion and hydroxide ions.
Oh, shit.
No, hydroxide ions, because it's H and OH to make H2O. Okay, so now the ions in water are going to separate, and the ions in the lattice in sodium chloride, they're also going to separate. And so these are the four ions that are going to be present in the electrolyte. Now what happens? Both of the positive ions will be attracted to the negative cathode. Sodium and hydrogen, but which of them will be discharged? Will hydrogen be discharged or will sodium be discharged? Only one of them can be discharged. So which one will it be? Hmm? Which one will it be?
Hydrogen.
Why? Why hydrogen?
Because in that series, hydrogen gets discharged faster than sodium.
Why? Sodium is above hydrogen in the reactivity series. So why is hydrogen being discharged and not sodium? Because the higher you are in the reactivity series, the lesser the ease of discharge you have. So since hydrogen is below sodium in the reactivity series, it has a greater ease of discharge. Therefore, hydrogen ions are preferentially discharged as hydrogen gas. Is that clear?
Yes.
Okay. So if hydrogen is below sodium, then hydrogen will be discharged and it leaves off as hydrogen gas. And the sodium ions will remain in the solution. On the other hand, the negative ions are attracted to the positive anode. Now which one will be discharged? Hydroxide ion or chlorine ion? Chloride ion.
Hydroxide, I guess.
Why?
हाइड्रोक्साइड में वो नीचे ना उसमें इलेक्ट्रोकेमिकल सीरीज के ना बट अगर ये कॉन्सेंट्रेटेड होता तो क्लोरीन जानी थी.
Yes. So since hydroxide ion is below chloride ion in the reactivity series, so it has a greater ease of discharge, and so it's preferentially discharged to form water and oxygen gas. But if it's concentrated, then chlorine will be preferentially discharged. Over here, they're showing a concentrated solution, which is why they are showing chlorine as discharged. Otherwise, if it's dilute sodium chloride, then the hydroxide ion will be discharged to form water and oxygen. And these are the ionic equations. Now, for example, it's a dilute solution. So hydroxide ion and hydrogen ion got discharged. What is the effect on the electrolyte? Yes, it gets more concentrated. And why? Because hydrogen and hydroxide ions are escaping, they're leaving, which means that more sodium and chloride ions are left in, if you compare the ratios, which is why sodium chloride gets more concentrated. But if it was concentrated sodium chloride and chlorine was preferentially discharged as shown over here, along with hydrogen. So hydrogen and chlorine escape as hydrogen gas and chlorine gas. Then what is the effect on the electrolyte? Yes, so it becomes alkaline. Why? Because sodium hydroxide is over here, and we all know that sodium hydroxide is alkaline. So that's the effect on the electrolyte. Now, after that, we're going to discuss the electrolysis of molten lead bromide. Yeah, this is a simple electrolysis where you do not have active electrodes, the electrodes are inert. So can anyone tell me the ionic equations at the anode and the cathode?
Molten lead. PB plus 2 electrons इको और वहां पे जाके वापस से PB हो जाएगा. उसमें बनेगा आई थिंक कैथोड के ऊपर.
Yes,
Anode,
you're
anode,
right
yeah.
for you're right for the cathode. And at the anode, bromine ions will lose electrons to form bromine, and at the cathode, lead ions will gain 2 electrons to form lead. So what is it going to look like? You're going to have these solids formed. Then the electrolysis of dilute sulfuric acid. Now what will happen? What are the reaction? What are the equations?
One would be hydrogen, so it will be 2H plus plus 4 electrons. No, 2 electrons, 2H plus equals to H2. That will be for hydrogen. And for anode, cathode के ऊपर ये होगा, anode के ऊपर आपके पास oxygen का होगा. 4
It was
AOH
4
minus.
electrons. You were correct in the start. So 4 electrons at the cathode. Because we
अच्छा
need to
नहीं आपने तो
balance
पहले ही कर दिया ना. हाँ
we
वो
need to
उसके साथ
balance
बनना
the
बनना.
equation. And over here, as since hydroxide is below in the reactivity series, so it's going to be preferentially discharged as water and hydrogen gas and oxygen gas. I'm sorry, and oxidation occurs at the anode. And over here, we can deduce the formula of water. We can see according to the reaction at the anode. Now we need to perform the electrolysis of aqueous copper sulfate with carbon electrodes. It means that the electrodes are active and they are going to take part in the reaction. So what is going to happen?
So hydroxide anode, it will be oxygen will be formed and copper will be formed in the cathode because copper is below in the series, electrochemical series, in rather than hydrogen. So वहाँ पे एक cathode पे copper बनेगा आपका और hydroxide oxygen बनेगी anode पे.
Yes, you're right. And so that's correct. These are inert electrodes because they're carbon. They're made of carbon. So there is the electrodes don't involve in electrolysis. So over here again you have oxidation and reduction. At the cathode, copper is formed, and at the anode, water and oxygen is formed. What is the effect on the electrolyte?
Hydroxide ions are acidic. It would become acidic because sulfuric acid would be formed as hydroxide ions are leaving. Only H plus ions will be left.
Very good. So you have H plus and SO4 2 minus ions left. So it's going to become increasingly acidic. And there are 2 more observations.
Oxygen gas is produced, so there will be bubbling of colorless gas. And pink metal will be forming on the cathode.
Yes, very good.
That's copper.
A pink metal is formed, so because copper is being formed. Over here you can see in the equation, copper is being formed, so a pink solid metal is formed. And the third observation is also related to color. Whenever you have copper, there are 2 colors that should come to your mind. One is
Brown,
pink if it's
brown.
in solid form, no. And the other is blue if it's in aqueous form. Copper sulfate, aqueous copper sulfate, it will always have a blue color. If copper is copper ions are converting to solid pink copper, that means that it's going to lose its blue color that was initially because of the copper ions in solution. Since copper ions have a blue color, and copper as a solid has a pink color. So the solution will decolorize. It will turn from blue to colorless. Is that clear?
Okay.
Now, if we have a copper anode, which is an active anode, what difference will we have? What will be different here now? Your anode is also made of copper.
Not sure about this.
Okay, so you have aqueous copper sulfate with copper anode and copper cathode as well, you could say. So what will happen? What are the ions present here? You have copper ion, you have sulfate ion, you have a hydrogen ion, and you have hydroxide ion. These are the 4 ions. Now, sulfate ion and hydroxide ion both will be attracted towards the anode. Now, what will happen? Copper, the solid copper, the anode is going to convert into copper ions. This anode is made of copper and it's active, so it's going to convert to copper ions and it is going to move into the solution. What happened? The negative ions move towards the cathode. The negative ions are sulfate ions and hydroxide ions, and when they were attracted towards the anode, copper lost 2 electrons so that those electrons could be given to the negative ions. It lost those electrons and it formed copper ions. Now copper ion dissolves in a solution. Copper ion is, you will find it in aqueous solution. So you have more copper ions in the solution. Copper ions were already present in the solution because you had aqueous copper sulfate. Now the anode, which was pink in color, the ions are going to now move, the copper is going to convert into ions and it's going to move into the solution. And so what will happen to the anode? What will be the effect on the anode?
Anode it will start to shrink in size.
Yes, its mass will decrease.
Decrease.
And what will happen to the electrolyte? What will be the effect on the electrolyte?
Change in color, I guess, or
Why?
solution. I don't know. Basically.
Okay, so let's have a look at the next step as well. So then we'll understand what will be the effect on the electrolyte. Now you have more increasing copper ions in the solution, but these copper ions are moving towards the cathode. So the positive ions are moving towards the cathode, hydrogen ions, and the increasing number of copper ions are moving towards the cathode. Now what happens? Since the copper ions will be preferentially discharged, as copper is below hydrogen in the reactivity series, it has a greater ease of discharge. So it is going to be discharged and these copper ions are now going to form copper.
Okay.
But where is it going to form copper?
On the electrolyte?
On the electrode. So what will be the effect on the cathode?
Cathode shrinks. Itna pata hai, uske baad I don't know.
Cathode increases in mass.
Oh, sorry, it's anode. Sorry,
From the anode, copper is converting into ions. So it's decreasing in mass, and these ions are moving to the cathode, and it's forming solid pink copper, and so the cathode is increasing in mass. Okay, now your anode is decreasing in mass and your cathode is increasing in mass, and what is happening to the number of copper ions in the electrolyte? Do they increase, do they decrease, or do they remain unchanged? Yes, they remain unchanged. Why? Because the ions that are forming at the anode, they are now going to the cathode and they are forming a layer. Now, another observation on the cathode increases in mass and the cathode also is coated with a reddish brown layer of copper. So these are 2 observations for the cathode, 1 observation for the anode, but there is no observation for the electrolyte. The electrolyte does not increase or decrease in concentration and it does not change color. Since there is no net loss or net gain of copper ions at the end, that's why the electrolyte remains unchanged. So the only thing that happens is that the electrodes are changed. The anode is losing mass and the cathode is increasing in mass, and it is also having a coating of copper, reddish brown copper. This is also used to obtain pure copper from impure copper, this method. So can anyone tell me that if we are using this industrially to purify copper, now will my anode be the pure copper or will my cathode be pure copper?
Cathode will be pure copper.
Cathode will be pure copper and anode will be impure copper. That is correct. So from the impure copper, copper ions will move to the cathode. So we will have pure copper at the cathode, and at the anode, we will have all the impurities left. What will happen to these impurities?
वो it will settle वो वहाँ पे sludge बना देंगी, मिस ने बताया था, I guess.
Yes. They're going to form anode slime. They're going to settle at the bottom or sludge, and you will have eventually all the anode will completely finish. And you can use the very same method to electroplate any material. So say this copper cathode is now a spoon, and so all the copper ions are moving towards the towards the spoon, and the spoon is becoming coated in a layer of copper. So you copper plated a spoon in this manner. Electroplating is the process of depositing a layer of metal on another substance using electrolysis. These are the ionic equations. Only copper gains or loses electrons here in the electrolysis of aqueous copper sulfate, and this can be used to purify copper from copper plate objects. Now, if we look at the electrolysis of dilute hydrochloric acid, so we have hydrogen ions, we have hydroxide ions, and we have chloride ions. What happens? Hydrogen is discharged as hydrogen gas, and from chlorine and hydroxide, chlorine is discharged at the anode. Now let's have a look at the electrolysis of water. So water is a very poor conductor, and so it cannot conduct. What should we do to it? We can either add a little bit of sulfuric acid, or we could add sodium chloride or any such thing to slightly improve its conductivity. And if we do so, then we can easily perform its electrolysis. And water is split into hydrogen and oxygen. So we also discussed electrolysis. What happens in electroplating. Now let's move on to this simple cell. So in electrolysis, we were using a battery to provide electricity, but in a simple cell, we just use the differences in the materials of the electrodes to generate voltage or EMF. A simple cell is a device that converts chemical energy into electrical energy. It is also known as an electrical cell. What's happening? What's the chemical energy? It's the potential difference between the two electrodes. Zinc and copper are two different materials. They have different reactivities. So potential difference is generated. A voltage is generated across the cell, due to which there is a flow of electrons. So let's say we have dilute sulfuric acid in the solution as our electrolyte. What will happen? Now when you have a potential difference generated, so the electrons from zinc are going to move to copper. Why? Because zinc atoms will give up electrons and they will oxidize, and these electrons will now be moved to copper. And it's necessary for both the electrodes to have different materials for a potential difference or a voltage to be generated. Now, then what happens at the hydrogen ions will now accept these electrons. Zinc let go of electrons. Zinc was oxidized, and over here the electrons move towards the copper side. Hydrogen in the solution accepted those electrons, and it formed hydrogen gas, and it left. So what is left in your solution? Copper sulfate. Copper is the positive electrode. Why is copper the positive electrode? We need to connect that to the reactivity series. Now, how do you decide whether you should which substance should you have at which electrode? So the more reactive metal is the negative electrode, and the less reactive metal is the positive electrode. So since copper is less reactive as compared to zinc, so zinc is the negative electrode and copper is the positive electrode. But say the electrolyte was copper sulfate instead of dilute sulfuric acid. What would happen then? Zinc atoms would once again give their electrons to form zinc ions. Oxidation will occur, and at the positive electrode, instead of hydrogen being discharged, now copper will be preferentially discharged and it's going to form solid copper. So what will be left in the solution? Pink solid copper. You'd have hydrogen ions and sulfate ions, and zinc has also formed ions, so it's also in the solution. The overall ionic equation would be Zn solid plus Cu2 plus ion aqueous forms Zn2 plus aqueous plus Cu solid if you combine both the ionic equations. And the further apart the two metals are in the reactivity series, the greater the voltage produced in the cell. So potassium and silver are the furthest apart, so they're going to create the greatest voltage in the cell. That's it for electrolysis.